Hi everybody, I should probably start out with introducing myself. My name's Eric Moore. I'm a sustainability manager at AMP Capital, where I oversee their office and logistics and retail portfolios and implementation of the 2030 strategy therein. You can probably hear from the accent that I'm a Scotsman. So if you can't understand what I'm saying, that's your tough luck. But I also, as well as being a sort of proud Scotsman, now live in Bidjigal land in Maroubra of all places, or also known as the place of thunder. So if you get the great opportunity of coming down to Maroubra at some point and experiencing the surf down there, I would be very welcome to have you down there. We're obviously meeting today on Gadigal land of the Eora Nation. And as part of that, I would like to pay my respects to their elders, past, present, and emerging. So we're meeting today to have a bit of a discussion about embodied carbon in building services. And we're very honoured to have an expert panel of varying experiences to be with us here today. The introduction to the country. Bit of a plug for CIBSE and TM65. So CIBSE's knowledge portal is an online repository of building services engineering. If you scan that barcode, you'll find a link through to the technical memorandum and applications manual and case studies and peer review publications and symposium papers. The TM65 series and the carbon calculator tour are available to anyone to download, noting that all guides are free to CIBSE members to download. So I guess that's really the plug for you all to become CIBSE members if you're not already such. And I would certainly encourage you to do so. Oh, before I go any further, I should probably talk about health and safety as well. For the people who are joining here in the room, I would like to point out if there is the unfortunate event of a fire alarm going off, please, the fire access stair is just behind you next to the core there in the green wall. Alternatively, you can go through the corridor. There's another fire door down there. Similarly, if you do need to use the bathroom at any point, there are bathrooms straight through the lift corridor access and to your right-hand side. Our host has also asked me to encourage responsible use of alcohol. We hope that you enjoy yourself, but certainly take it in moderation if you can. Some more about our those who have managed to fund today. I'd really like to acknowledge Connexus Recruitment for their support of CIBSE's ANZ annual programme of technical events. Consensus, for those that don't know, is a boutique recruitment organisation dedicated to ANZ's design and construction sector, with over a decade of combined experience recruiting exclusively within space. When they are consultants among some of the best industry and are proud to have connected talented individuals across the globe with some of Australia's most recognised consultancies. They are advocates for people and business in their journey to professional success, striving to bring back a consultative approach to the recruitment market. The key disciplines that they recruit for include building services, digital engineering, and project management. So I certainly didn't actually know Connexus until I stood up here. So I would encourage you, if you are looking to recruit anyone, or if you happen to be looking for a new job, go and have a chat with them. They're a great organisation to be working with. Also, a bit of a plug for our hosts at the moment. CIBSE and myself would all like to acknowledge the hospitality of WT Partnership. They are very kindly funding the drinks and the food, which you've got in hand at the moment. I hope that you enjoy those. And I think that you'd be joining me in thanking them for their patronage today. So, suppose on to the main content of the day. Today we're going to be looking at addressing embodied carbon in building services in Australia and New Zealand, and the implementation of CIBSE's TM65 and the ANZ addendum to that. Today we've got a panel of speakers, each of which will be giving a short presentation to you all, and then at the end we're going to corral again to have a bit of a discussion about the points around carbon and embodied carbon within the built environment and building services in particular. First up for you today, we've got Taryn Cornell, who hopefully needs no introduction, to be absolutely honest. I've worked with Taryn for a number of years now. and had a great time kind of developing some of the GBCA's roadmaps and guidance documents about electrification within buildings. My last kind of meeting with Karen was actually in spandex as she still passed me in the morning in her way to work thing, which was slightly confusing for me as I stood waiting at the bus stop, trying to avert the gaze of someone on a bike, and then ultimately had them say, "Hi, Eric." So that was a little bit of background between Karen and I. Prior to joining the GBCA, Karen actually worked for over a decade as interior and architectural design, specialising in high-end hospitality and residential work, with many years on-site project experience. After graduating from RMIT with a diploma in interior design, Karen has developed a detailed and considered approach to delivery and stakeholder engagement, which she implements at the GBCA, and has a passion for design outcomes and engagement with community and promoting societal benefits. Karen was actually also the author of TN65 ANZ and will provide a little further background. Well, and I say an author, certainly one of the people bringing it to the country, and how ultimately this methodology works with Green Star. If I could maybe invite you to the floor, Tan, just kind of for your presentation, and join me in welcoming Tan.
Thanks everyone, and hi to everyone online as well, because I know this is in the near future post-COVID, we're looking at we're doing this across different platforms, so this is a new and different experience for me for sure. Thanks for that great introduction, Eric. It's true, I in addition to working at the GBC and overseeing the development of Green Star, I do occasionally like to dress up in micro and ride around on a bike. I'm going to talk to you a little bit about upfront carbon and the context of TM65 and why we thought it was really important that this is something that we bring to Australia and New Zealand. So the GBCA has developed a number of things in addition to Green Star. Upfront carbon is an aspect of the built environment and a climate positive pathway that we've established. But that's something that we've been talking about for a while. So in 2018, we released the Climate Positive Roadmap, which talked about all the things that the construction and property industry need to do in order to meet those net zero outcomes in line with the Paris Agreement. And that really sets the trajectory of all of the things that we need to do. We released in 2020 Green Star Buildings, which is the new Green Star rating tool for design and construct. And in that we have a minimum expectation that every building that gets a Green Star rating has to have at least a 10% reduction on their upfront carbon. And then we reward you for going up above and beyond that. And then in addition to that, we work on a global scale as well with groups like the World Green Building Council. They have the net zero carbon buildings commitment, and recently they updated that to also include an aspect of embodied carbon. So these are kind of the big drivers from our perspective. There's lots of other drivers for why embodied carbon is something to address, but from a kind of a policy and a roadmap perspective, these are the things that we've been working from. When we talk about emissions in a building, there's a lot of discussion, I think, about scope 1, 2, and 3. But really what we wanted to do is to just essentially look at these are the emissions that we need to think about in a built environment. So scope 3 can definitely go on and on and on. But when we're looking at the emissions associated with property and construction and buildings, you can see there that black bit represents materials and products, and so it's not an insignificant amount. Although operational carbon is always something that we will focus on, and there's still lots of strides to go. That scope 3 and the kind of product and material aspect of this is really something where the conversation is not quite as advanced as it is around operational carbon. And that's really illustrated by this particular graph, where you can see in 2019, operational carbon really accounted for 84% of those carbon emissions in Australian buildings, and the kind of embodied carbon or upfront carbon aspect is 16%. Fast forward to 2050, where we're really looking at a grid powered by renewables, more electrification. That embodied carbon becomes a much bigger proportion of what the building actually has. The other thing about embodied carbon is that it is locked in. So I will talk a little bit about the difference between embodied and upfront. But essentially, that is locked into a building at the start of operation, whereas operational emissions you can play with over time. Embodied carbon is something that gets locked in, and those decisions are made early in the piece, and it's very hard to change those decisions once that building has been constructed. This is kind of in terms of that similar context. So you can see here, this is kind of a graph of how that will change over time. So the orange is those operational emissions coming right down, and you can see that that embodied carbon then becomes a bigger proportion of the pie. But also we're looking at the area of constructed, the area of the square meters of constructed space in Australia is also on the rise. So thinking very hard about what we reuse, how we reuse that, how we recognise that is really important. And then just at a national level, looking at it across the life cycle stage, across different sectors, you can see that the building products do take up of that, the kind of embodied carbon. So for those life cycle assessment folks amongst us, the A1 to A5, you can see that the building products takes up the kind of lion's share of those emissions. And Matt is going to pick up a little bit later on this in a bit more detail, but this is just to say that when we're looking at that embodied emissions or those upfront carbon emissions across a typical office building, you can see there that mechanical and electrical sit at about 10%. At best, that's a guess. So it's an educated guess and it's an estimated guess, but compared to something like substructure, superstructure, cladding, we have a lot less transparency in the supply chain, and we're doing a lot more rounding when it comes to those. So it could be that that actually is a bigger portion of the pie when it comes to services. So there's a gap to fill essentially. As part of the World Green Building Council, we sit on a number of committees. One of those is the Advancing Net Zero Committee. And you can see here on the right, Clara, she's also a part of that committee. She represents, I think, Letty from the UK. And that is a platform for sharing knowledge. And she mentioned one day, oh, we've been working with CIBSE on developing this TM65 guidance. It's a calculation methodology for establishing a consistent way of understanding what the upfront carbon impacts of services and mechanical are. And we said, that's interesting. We've been thinking about this a little bit and we would love to talk to you. So we partner with CIBSE and so CIBSE Australia and obviously Integral to look at how we could bring that to Australia. So essentially looking at taking a standard that was developed for the UK and how we could bring that into Australia. So we set up a group of experts. We had some really robust discussions about how we would develop this particular guide, and we've given it, we had some great feedback. We've implemented that and we've essentially published TM65 ANZ, which is really exciting. It's definitely the first step in a process, and Matt will talk to you a lot more about the kind of detail of the guide. But we're really excited that we have this opportunity to partner with CIBSE on bringing this specific guide to Australia and New Zealand. So just looking at Green Star in particular and what's driving the TM65 as the uptake of TM65 and also how we would recognize that under the rating tools. So under Green Star, we're doing a whole big revision of the rating tools. As I mentioned, we released Green Star buildings earlier, in 2020. But under all of these particular rating tools, there's an element of addressing upfront carbon, and that's part of a bigger climate positive pathway. So it's not about leaving anything behind. It's about thinking about carbon in its whole. But as I mentioned, understanding specifically that upfront carbon impact and how we can influence that across the supply chain is really important. Green Star Buildings is looking to drive opportunity for supply chain transformation in two key areas. So the first is that specific upfront carbon aspect and driving a market for low carbon products. And so that's really what where TM65 can fit in terms of at least recognizing that you've done some calculation around the upfront carbon in your supply chain for those particular products. The other thing that we're doing, which isn't an explicit or specific look at carbon, but is an important thing in terms of the context of products and materials and the supply chain, is a new definition for responsible products. So what that's doing is effectively creating a set of criteria that outlines what a responsible product looks like, and then asks you to demonstrate using third-party certification schemes, how comprehensive you are against that. So as I mentioned, the upfront carbon piece is really one piece of the puzzle of delivering a climate positive building. So when we're talking about climate positive buildings, we're talking about fossil fuel free, highly efficient buildings that are powered by renewables, built with lower upfront carbon and offset with nature. So it's all about reduction, reduction, reduction until you get to that final bit and then offsetting. We recognise upfront carbon and embodied carbon in two different ways. So there is the full life cycle assessment that we recognise in Green Star, but I have been banging on about this upfront carbon thing, and that's just to really explicitly say that the upfront carbon is your A1 to your A5 modules. And that is a really, important distinction, because although life cycle assessment looks at the whole life cycle, and that is very important, the upfront carbon emissions are, as I said, what you lock into the building on day one. And so you can make a lot of decisions about what actually goes into a building and affect that upfront carbon profile if you're very conscious about what it is that you're procuring, how you're designing, what you're designing out, etc. And then this responsible products framework. So as I mentioned, it's essentially a set of criteria. We do this by breaking down the building into 4 key aspects. So responsible structure, envelope, systems, and finishes. And the reason that we do that is because we recognize that for each of those aspects of the building, those supply chains are at different levels of engagement and I guess sophistication in terms of their understanding of being a kind of a responsible product. So responsible structure, for example, has a lot higher benchmarks in that particular credit, because concrete and steel companies have gone a long way to essentially, doing a lot. Partly that's because they have very simple supply chains and a much more controlled manufacturing process. It's an easier thing for them to do. Systems, however, we essentially established that that is a huge area for improvement. So the benchmarks under systems are a lot lower. So as I mentioned, it's essentially about looking at against the framework, how you perform against this category. And I'm not going to go into detail about that, only to say that under the section here of positive, we will recognise anybody who goes and talks to their manufacturer, does a TM65 assessment, and essentially, reports that back to CIBSE. So we're just wanting to recognise, moving in the right direction in terms of having those conversations and engagement. So before I hand over to our next speaker, I'm just going to have a little bit of a call to action, and that's really why we're here. It's imperative that when you're looking at upfront carbon, you are asking for an EPD. That is the highest order when it comes to understanding, the detailed impacts of what happens in a product. But we have a huge gap between the amount of products that have EPDs and information. So at the moment, I think when we did the review, you could list on one hand the number of services products that had an EPD. And that's a huge problem when we're asking for these big reductions and to get a lot more insight into industry. And so if you can't get an EPD, start with TM65, because that is essentially a discussion point, and it allows that conversation to begin. It also helps those manufacturers and suppliers go on the journey to then potentially getting an EPD down the line, and it gets them, halfway, 75% of the way to that EPD. And so we can't manage what we don't measure. And so this is all about making sure we're getting out there and measuring stuff. That's it from me. Thank you.
Thank you, Karen. That was fantastic. Some lift outs in that kind of presentation for me are locked in carbon. I like that piece, basically kind of, well, the grid is decarbonising. The decisions that we all are making right now are locking carbon, embodied carbon, into the designs of the future. Okay, that's a really key point for me. Building services, the carbon embedded is in effect a guess. Okay, we really don't exactly know what's going in there at the moment, and kind of, there's a real need for us to understand that more clearly. And really kind of GBCA's big call to action, basically the use of TM65 needs to kind of be brought to the fore. So kind of on to the next speaker for the night. Our next speaker is Egon Murphy, pronounced incorrectly or not? That was pretty bad. Egon is experienced quantity surveyor, kind of actually from here at WT Partnership, where he's been since 2017. He's got over 8 years experience in quantity surveying and as a cost consultant. He has gained valuable experience internationally, both working here in the US, in Ireland, and the UK. Today, Egon's going to talk a little bit about kind of issues with quantifying embodied carbon from a quantity surveyor's perspective. So, kind of please welcome Egon and kind of
thank you, Eric. Can everyone hear me? Okay, do I need this mic? No. All good. Like Eric, I have a funny accent, so if you can't understand me, just reach out and tell me to slow down. So I work with WT, have for the past 5.5 years. We're sponsoring the event tonight, which we are more than happy to do for such a important topic. So I'll just talk through what we're doing in the space as quantity surveyors, issues we face, and I'll speak briefly about the Atlassian project because it's the project on everyone else's lips. So why quantity surveyors? Why do we get involved? So as quantity surveyors, our key expertise is in the quantification of materials, which obviously lends itself directly to the calculation of embodied carbon. This skill set can be then used to set a benchmark and from that targets to reduce your embodied carbon. We can analyze different design scenarios and through each design phase we can tell you what the embodied carbon content is of your project. And once we've that done, the first question on most people's lips will be how much will it cost? Obviously, quantity surveyors, that's where we can come in useful. Sorry, I should say. So on the right of the screen, there is just an example of embodied carbon dashboard. We produce, steps you through the cost at each design phase, the embodied carbon content, embodied carbon in your building elements, and your procurement reduction. This is just another part of the report we produce. Again, it steps through the design process and talks to the embodied carbon content in the various building materials. So some of the issues we face as quantity surveyors is the variable information out there. So you all know tools and databases that are out there. I'm sure you're aware of them. Down the bottom of the screen, I've just done a quick little comparison on some popular building materials. So, for example, 40 MPa concrete can vary from 357 kilos of CO2 per meter cubed up to 539, depending on your database which you're using. These variable sources of information, or disparity in information rather, can lead to different outcomes, particularly when you're setting a benchmark. Another issue or experience is because this is emergent science, the industry is not fully across what we do as QSs, but what we're trying to do in the broader picture. Everyone's coming out and saying, look, we need to reduce our embodied carbon, but some people don't know what it is and how to reduce it. One of the biggest issues is that we don't have industry set standard here in Australia for the reporting and measurement of embodied carbon. I know neighbours are currently working on that. I think they'll provide an update to the industry for comments this year and towards the end of the year, and hopefully finished product in the middle of next year. And huge issue we're facing is building services. Up until now, there's been no methodology or data out there to calculate the building services, but TM65 to the rescue. So the Atlassian project, I will say before I start on this that I was not directly involved. The embodied carbon piece on this project was very much a collaborative piece between the engineers, architects, building owners, full design team, and builder. And there's very strict confidentiality agreements in place in this project, so I can't go into too much detail. But what I can say is, so it spent 6 years in design. Construction started on site in August, I believe, and will run for 4 years. The target embodied carbon reduction from the preliminary design was 50%, which obviously there was need to set a benchmark. Atlassian is not purely a timber frame building. It's a hybrid frame, concrete and steel, with timber floors as neighborhoods. On this project, approximately 85% of the embodied carbon calculated was in the superstructure and facade. So the focus to reduce those elements was on the use of cement replacement products and the use of green steel. The thing with green steel is there's only a handful of countries out there that produce green steel. So what you may benefit in going with green steel may be squandered getting it to Australia because distances are so huge. And I think that's it for me, short and sweet. I'll hand it over to Eric.
Thank you, Egon. Couple of takeaways for me in that one. Go have a chat with the quantity surveyors. They're used to dealing with data and they're in safe hands. We are looking at carbon assessments for them. And I particularly like the discrepancy in numbers for glue lamb timber, to be absolutely honest. I think that was a 2,300, like a minus number all the way up to 1,700. That was a fairly substantive kind of discrepancy between the two. So the third speaker for the day is Fairouz Ghanem. Hey. Thank you very much. Fairouz joined the Northrop sustainability team to fulfill her passion for meeting the world's need to reduce high impact on the ecological system, along with enhancing the human experience in buildings. She is passionate about building physics, enjoys working on diverse sustainability projects focusing on energy efficiency optimization, NCC Section J, life cycle design, Green Star, and WELL certifications. At this event, Fairouz will talk about her experiences with life cycle assessment and the need for a uniform approach to the calculations therein. Welcome her to the stage.
Hi everyone. My name is Fairouz Ghanem. I'm a senior sustainability consultant in Northrop, and I'm leading the life cycle assessment team as well. So, as part of our job as sustainability consultants, we work in like different building typologies. So we work with commercial, retail, industrial, and fit outs. So long time ago, when we started doing our life cycle assessment, like we started our life cycle assessment journey, it was basically around ticking boxes. So we're just trying to tick boxes basically to satisfy requirements from certification. But that was like really long time. Nowadays, what's happening, a lot of change happening in the industry. So with the certification schemes, different certification schemes are asking for more details. So more requirements with more details on life cycle assessment that is requiring more like understanding about the different impacts for different materials and to drive and improve the environmental outcomes. Also, it's not just about certification. So a lot of our clients are also now asking about embodied carbon reduction. So a lot of them got really excited. It was really good about life cycle, about embodied carbon and how to reduce it, and made a lot of like public commitments. So all of these public commitments are very ambitious, and we're being asked now to not just to do life cycle assessment. We're being asked to define benchmarks. We're being asked to provide guidance, to do strategy guides for and standardized LCA process to improve the outcome. And that's like really good. But the thing is, we do have the experience and understanding for different building elements, and have been doing that for some time. The part that is really tricky and was always treated as a big closed box and treated as like a whole was the building services elements. The reason for that is that building services can get really complex. So we know that there are two aspects for carbon and building services. We have the operational carbon and embodied carbon. With the operational carbon, we know that we talk about like energy efficiencies. We know how to do it. But when we come to embodied carbon now, the conversation was a lot lately about like refrigerant gases, using refrigerant gases, natural refrigerant gases. But when it comes to the materials, it gets a bit complicated. So we don't have enough information about like the quantities in building services materials. Where are they coming from? What are their actual impacts? And because I work with wide range of engineering disciplines in Northrop, that's why I understand the struggle in getting these accurate information about different materials. And that's why we actually need an actual framework to guide the whole industry on how to improve these environmental outcomes, at least in building services. So the main thing is that we need to first understand the information, understand what we have, what we're dealing with, and then we get this information and analyze it. And after analyzing this information, then we can improve outcomes. So without these three steps, it's really hard to achieve better outcomes. I'm going to explain more about these three steps. So when we talk about understanding, we face two things. First one is transparency. So the problem in this area is there is a lack of public data about building services materials, where they come from, quantities, what do they actually include. And without that information, we cannot actually get, we will not be able to basically improve. We also need incentive for people to share that type of information. Comes another tricky part is like that the building services can really be complex, and all of these components are really complex. And from experience, complexity really drives people away from understanding. Like, it's too complex, I don't want to look into that. And we need, because of that, we need to simplify the approach. We need to have something to kind of help us simple approach to collect data, to calculate the impacts, and then we should provide some flexibility also about the amount of detail that can be included. We shouldn't be like forcing people to actually dig really deep into that. And that's actually the main goal for the TM65. So it's basically about transparency. So after we gather the information, we need to analyze this information. And that can be a bit tricky because exactly what, touching base with what Aiden said, when we gather the information, we get the life cycle assessment. You can do life cycle assessment for the same project by 2 different consultants, and you get different results depending on the database they are using. And the issue is like none of them is wrong. It's just they are using a different source of information. They are dealing with different methodology. They have different framework. And the thing is, we're not trying to persuade everyone to use the same source, but at least we can refer to one thing using the TM65. Only then we can have comparable. So instead of having like completely different results, we have comparable results. We can look at the results and start basically analyzing. And then when we have that framework, it can be repetitive after that. So basically the TM65 is about transparency, it's about a uniform approach, it's about flexibility. So we're not trying to solve everything at once. We're just trying to focus on one problem right now to fix it instead of struggling with different aspects. And also, we're trying to not to make the perfect and trying to get everything perfectly right to be the enemy of good outcome. So we're just trying to agree on an approach to use by everyone. And we're getting some success, and like a lot of success actually in this, by the TM65 being adapted by Green Star now, and neighbors in their new tool about embodied carbon, that's a sneak peek. They're gonna actually use it. A lot of conversation happening in this one. And once we get all of this applied, then we can actually look at improvements, because we're going to have actual benchmarks. We can have benchmarks to compare against. We can have benchmarks to improve against, and then we're measuring success against the fixed numbers. But that also cannot happen without the industry collaboration. So everyone would, like, by using one uniform approach, everyone would feel safe sharing their knowledge, because we're referring to one source of truth. So sharing knowledge and trying to improve outcomes only can come by the whole industry gathering together to try to get that better outcomes. And like getting back to my when I talked about our clients and the developer trying to improve, this is a very good guidance and a simple guidance for them on how to achieve the outcomes and what they promised publicly as well. And the details of that would come by Matt, the technical details on this. So handing out to him. Thank you very much.
Well, thank you very much. I thought that was awesome. Couple of takeaways from me in that one, really. Carbon is a key issue, and people are asking right now. They've got lofty targets, and kind of ultimately how are we supporting them? Building services are traditionally tough. You know, we've got to understand, analyze, and improve. I really liked your point about understand and the simplification of the data, basically, in those different kind of layers of kind of context, and kind of taking what is a super complex issue and trying to bring it down to kind of a simplified or methodology, which ultimately we can take one step at a time. I think that's a really good part of it is, you know, the great being the enemy of good. We need to take the first step. We need to get somewhere. This is the methodology of actually doing that. Anyway, all right. Next speaker for the night, the final speaker for the night, for that matter, in fact, Matthew Sykes. Matt is an associate principal at Integral Group's, and he is the national sustainability team. He's got a career spanning some 16 years across two continents. Sorry. As Integral's Australasian carbon sector leader, Matt works with clients to decarbonise buildings, precincts, and organisation, where Matt is passionate about delivery of healthy and happy places with the lowest possible whole-of-life carbon impact. And today, Matt is going to be taking us through, in a bit more detail, TM65 methodology, its application, and kind of how we actually use it at the end of the day. So, Matt, what do you think?
Thanks, Eric. Yes, so yeah, my name is Matt Sykes from Integral Group. I actually work in our Melbourne office. So I've just popped over for the evening tonight to present for this event. So that's why I know nobody in this room. So nice to meet you all. I will start by a lot of this has been covered by the other presenters, but it's worth reiterating this issue. What is the problem that TM65 has been created to try and solve? Well, just stealing one of Taryn's slides, which she did source elsewhere, actually. So, source from Greengage, a UK organisation. But yeah, this shows that in a typical commercial building that the services are around 10% of the embodied carbon. But as Taryn mentioned, that is at best an educated guess. And why is that? Well, the problem we've got in the building services industry is a lack of data, a knowledge gap. Regarding building services products. So environmental product declarations, or EPDs, are the global standard for product lifecycle impact declaration. And an EPD is a standardized way of disclosing these environmental impacts, including embodied carbon, and it's a really rigorous, consistent and peer-reviewed methodology. But as has been mentioned, there are only a handful of building services products that actually have EPDs. And that's because they can be quite expensive and time consuming to produce. And when you consider this in the context that a lot of the suppliers that we deal with have a huge range of products, that's a very daunting task to try and create EPDs for a full product range. And we are really interested in understanding the embodied carbon impact of services because they are potentially very high impact. First of all, there's lots of stuff in a building. So in a 2-story, 2,000 square meter building, it's not uncommon to have 20 to 25 tons of services equipment when you add it all up. There's a lot of material there. Also, services equipment uses high impact materials, metals like aluminium and steel, synthetic refrigerants. And the other big thing is the high replacement rate. So the initial upfront impact of services may be 10%. We know that most of that upfront impact is in the building structure, but the building structure hopefully lasts for the whole building life, whereas services equipment is replaced periodically at 5 or 20-year periods, depending on what the component is. So when you think about embodied carbon and that repeated impact over the life cycle, services can be huge. So this is why TM65 was written. So my colleagues in the UK, at Elementa, who are our sister company in the UK, wrote TM65 to tackle this problem, which is a lack of data, a potentially high impact sector of building services, and of course, our urgent need to understand, measure, and reduce embodied carbon within buildings. So what is TM65? Well, the aim of the TM65 methodology was to create this consistent methodology to assess embodied carbon in building services equipment when there are no EPDs available, which is most of the time. And the goal is to collect data and make industry research studies possible so we can start to understand our impacts as a sector. And the hope is that TM65 will help building services engineers and help our supply chain to better understand our embodied carbon impact, and also enable better engineering decisions so we can actually use whole life carbon thinking to influence our decisions while we're waiting for EPDs to become more mainstream. So TM65, it's a method for estimating embodied carbon in building services equipment. It's a first step to promote transparency in the supply chain. Our suppliers that we deal with have not been traditionally asked about embodied carbon. This is starting a conversation. It's a simple replicable standard, but what it's not a whole life cycle assessment at system level. It's not an environmental product declaration, EPD, and it's not trying to be. This is definitely a stepping stone on the way to an industry that needs to produce more EPDs, but it's not going to do that in the immediate future. And it's not a method for comparing the embodied carbon of product A and product B. So that's a really important point, that we shouldn't be using this method to collect data on, say, a heat pump from one manufacturer and then another and comparing the embodied carbon, because you do need an EPD to do that. You need the rigor and detail of an EPD. This is about collecting industry-wide data. So how does the TM65 calculation fit into a whole of life carbon assessment? So when we talk about whole of life carbon of the building, we're talking about all the embodied carbon and all the operational carbon over the life cycle of the building. TM65 sits in the embodied carbon part of that. It doesn't consider operational carbon. And it just looks at building services. So everything else, structure, facades, internal finishes, all the other materials, doesn't consider those. And then even within building services, it's just looking at product level. So it's not considering the quantities of products in a building, so the system. It's not considering the service life. It's just looking at the products, individual products. So what's the process? Well, it's fairly straightforward. There's a 3-step process. The first step is data collection. So data is collected from manufacturers through a questionnaire form. And then once you've received that data, we undertake calculations. There's 2 calculation methods, depending on the amount of data you can get from your supplier. There's a basic calculation and a mid-level calculation, which is obviously a little bit more detailed. And then the final stage is reporting. And this is the most important part of this, because as I mentioned, this is about collecting data from the industry. So reporting the results back to CIBSE, so it can be entered into a database, and then we can look at trends and patterns in the data is probably the most important part of this process. And just to show that basic versus mid-level versus an EPD, obviously the basic calculation is fairly easy. Mid-level calculation is a little bit harder, but it's nowhere near as hard as a full EPD. And then in terms of manufacturer involvement, very little manufacturer involvement required for the basic level TM65 calculation, a bit more for the mid-level calculation, that an EPD is much more of a commitment from the manufacturer. And then again, the level of detail again steps up as you go from basic to EPD. And the reason that we think this is a really good conversation starter for suppliers is that it doesn't involve that level of commitment and involvement that an EPD does. I think if you went to a building services supplier, equipment supplier now and asked for an EPD, you wouldn't get much traction, to be honest, because it will be a lot of cost, a lot of time, resources, things like that. Whereas this is a way where we can start to understand embodied carbon through much less effort, in a way. There is, I'm not going to go to this now because it's really complicated, but there is in TM65 a really detailed comparison of the inputs and the data required for each of the two calculation methodologies versus an EPD, which, if you're into that kind of thing, is quite an interesting little piece to look at, because it really just shows a difference in the amount of data required and the rigor involved in each of these methods. So going back to this three-stage process, how do you do TM65? So the first stage is data collection, and this is done through this manufacturer's form. There's three sections, section A, B, and C. Section A is essential information, and this covers kind of standard information about a product that you could probably get most of it off a data sheet, other than one item which is highlighted there, which is material composition breakdown. This is where the manufacturer will probably need to do a little bit of work to understand what, by weight and by type, the material breakdown of their product. So that's essential information. Without section A, you can't do TM65. Section B is supplementary information. So that's a bit more detail on things like where the factory location is, how much energy does the factory where they produce the product use, where do they source some of their components from. And that's not mandatory, but you do need that to do the mid-level calculation. So to do the mid-level calculation, you need section A and B completed. Section C is totally optional at the moment, and it is looking at broader impacts, such as the annual waste output of the factory where the product's made, the annual water consumption, how much renewable energy is that factory using. And this is optional at the moment, but this is being requested to help develop future iterations of TM65. Section C is not included in the current calculation methodology, but it can help to develop future versions. Now for these calculation methods. So once we have the data from the manufacturer, if they've only given us section A, then we go ahead and do the basic calculation. And it is fairly basic. So step one is to take those the material breakdown from part A of the manufacturer form, and then multiply each of those materials and quantities by a carbon factor, which is based on the material extraction. So the raw material extraction embodied carbon. Second step is we do a calculation for life cycle stage B3, which is repair. So essentially spare parts that are required for that component through its life cycle. And if we don't have detailed information on that, we assume that B3 is 10% of the initial A1 material extraction carbon. So just a kind of high level assumption that can be used without detailed data. Then step 3 is a scale-up factor. This scale-up factor accounts for all the other parts of life cycle stage A and B and C, which is disposal, that we haven't calculated in steps 1 and 2. And that is actually varied based on product complexity. So more complex products have a higher scale-up factor to allow for additional manufacturing processes, additional transport, and all that stuff. And then step 4 is a buffer factor of 1.3. This is because we want this method to be highly conservative. We don't want to be underplaying the carbon impacts of these products. So that's a safety factor in effect. And then step 5, we include the refrigerant impacts. So the refrigerant impacts of the use stage, so any leakage that might occur, and then the end of life processing of those refrigerants. And that's it. That's the basic method. It is fairly straightforward. The mid-level calculation is a bit more complex, as the name would suggest. So the step 1, whereas before we just looked at A1 material extraction, we still do that, but now these other parts of life cycle stage A, such as the transport of materials, the manufacturing process itself, they're actually calculated in more detail based on the data collected in section B of the manufacturer's form. And then the same with the end of life in step 2. So life cycle stage C. Previously, that was all included in the scale-up factor. Now we actually look at location, distances travelled, local waste processing processes, things like that in more detail to calculate the end of life. And then the repair stage, which previously was based generally on a 10% of A1, and it's now actually calculated every single component that's replaced with the product life. You actually undertake steps 1 and 2 for that individual component. So there's quite a bit more work in that. Then steps 4 and 5 are the same. We have a scale-up factor of 1.3 to allow for that, to make sure this calculation is conservative. And then we add on refrigerant, leakage impacts, and end of life. So a bit more to do in that one, a bit more information required. And then the final stage, again, probably the most important bit, is getting this information back to CIBSE. So depending on which calculation method you've done, basic or mid-level, there's a different reporting form. But there's been a lot of work put into making these quite consistent so that the data can be easily sent back to CIBSE for analysis. And just to give you a bit of an example of these two calculation methodologies, we took you can't see the title there, but it's a 542 kilowatt heat pump. And we got manufacturer data for sections A and B of the manufacturer form, and then undertook a basic calculation and a mid-level calculation. So you can see that the basic calculation on the top returns a more conservative embodied carbon number, as you would hope from a basic calculation. And you can see the impact of that scale-up factor there. We haven't actually got many inputs. It's just A1 and B3, material extraction and repair. The rest is done with a scale-up factor, and then we have the buffer factor. For the mid-level calculation, you can see how that returns a slightly lower, but probably more accurate embodied carbon assessment because of the more granularity of the calculation and the lack of the scale-up factor. But you can see how those different kind of results compare. So hopefully, if you can get the information, the mid-level calculation will provide you a lot more insight and detail and accuracy. And you would expect an EPD would return a lower embodied carbon impact in the mid-level calculation because it's gone to the next level of detail. So what can we do with all this product level data? We've already said it's not really for comparing product A to product B. So what do we use it for? Well, ultimately, we want to generate system level assessments using this data. So an example of this is TM65.1, which is the embodied carbon of building services in residential heating systems, which was released in the UK earlier this year. And what they've done with the product data is actually looked at trends. This example, I'm not going to go through these graphs in detail, but this shows the relationship for heat pumps of embodied carbon in kilograms of CO2 versus the kilowatt output of the equipment, or the kilowatt weight of the equipment. And you can see how we can start to develop trends and curves that describe embodied carbon versus certain other equipment parameters. And when this data was looked at over heating systems, I think products for space heating and domestic hot water heating ranged right down from 3 kilograms of CO2 per kilogram of equipment weight right up to 21, but the average was 9. So it gives you kind of these benchmarks that you can start to use early in your design to understand what the impacts of a system would be. And this TM65.1 analysis culminates in a system level assessment for each residential heating system that was analysed for various building typologies ranging from 10 townhouses to 2,000 apartment development. This example here shows a 100 apartment scheme. And then on the right there, it shows the upfront carbon impact of each system type that was assessed. And then below that is the life cycle impact, so the embodied carbon over the whole system life cycle. And when you take benchmarks like these for different system types, and you combine that with energy modelling, we can start to create a whole of life profile, carbon profile for buildings quite early in the design process, and refine that as we go through each design stage. So how do you use TM65 in Australia and New Zealand? As Taryn mentioned, Elementa our sister company in the UK, the Green Building Council of Australia, and CIBSE ANZ have recently authored the TM65 ANZ addendum. So TM65, the original UK document, is still the basis of the calculation. And to use the addendum, you read an additional document called How to Adapt CIBSE TM65 outside of the UK. The reason that's been done like that is, as you can see, although the ANZ addendum is the first, there are future ones currently being developed and planned. So it allows a bit of flexibility on, and allows these addenda to really just focus on the actual changes required in the calculation methodology to make them regionally useful. Sorry, pressed the wrong button there. Somehow. So what were the changes in TM65 for the ANZ addendum? Well, for the basic calculation, the only change was the refrigerant leakage scenario. The other, because it's such a basic calculation, we're just looking at raw materials and repair and refrigeration leakage. The rest is done through buffer factor. So the refrigerant leakage scenario is slightly different in our region. We make a different assumption compared to the UK regarding leakage over the life cycle and at the end of life, how refrigerants are dealt with at the end of life. For the mid-level calculation, there's a few more changes in the calculations. Calculations for transport were different, obvious differences in the geography of the regions. Things tend to be transported a little bit further over here than they are in the UK. Carbon factors for gas and electricity grids were adjusted to represent local data. Again, the refrigerant leakage scenarios were changed, but that's as per the basic calculation change. And then finally, the factors for disposal, the end of life products was changed to reflect our waste handling practices in this region. So what's next for TM65? So currently, CIBSE is working on updating an Excel tool so that all these calculations that we talked about earlier can be done automatically with the local ANZ addendum data. So you don't have to do it by hand. But long-term, the vision is to create a web-based tool so that manufacturers can input their data directly and cut the consultant out, which is great for us because it's less work, but it also helps to keep the data anonymous as well because it's going through less hands. But that's under development, not available yet. And then in the UK, as I mentioned, TM65.1 was a assessment of residential heating systems. Currently, again, my colleagues at Elementor in the UK are working on TM65.2, which is looking at embodied carbon of HVAC strategies for offices, again in a UK context. But ultimately, once we start collecting data in our region, this is the kind of studies that we need to produce for systems that are relevant to our building typologies here. We use different systems than they do in the UK, and we need to build up an understanding of those systems in terms of embodied carbon. So just a few key takeaways. We need to understand and measure and reduce embodied carbon. I think we all understand that. Building services is currently a real grey area, complete lack of data and transparency in the sector. And TM65 provided this methodology to benchmark equipment, establish industry averages where we haven't got EPDs available at the moment. But it's not for comparing product A to product B. It's really to collect industry-wide data. And with this data, we can create rules of thumbs and benchmarks that can help inform early design decisions and also make embodied carbon a key design driver for our industry. And it is certainly a stepping stone. We hope that introducing suppliers to this process and having a conversation with them about embodied carbon really spurs them on to produce full EPDs and for them to see the value in doing so. As Terry mentioned earlier, a big plus is that this is being recognised by Green Star Buildings under the Responsible Systems credit. I think if anyone's looked at that credit, it's very hard to score points in it, but there's an opportunity here if we're doing a Green Star project to also get some credit for doing these investigations. And finally, the ANZ addendum was released at the end of September, so just at the end of last month, so it's ready to use, and we encourage you to do so because we really do need to start to understand the impact of our designs, to be able to measure them and then hopefully in the long term reduce our impact. Thanks.
Well, I'm not going to try and even try to summarize what you're going through there. So well done. Thank you very much for that. We are going to have a panel discussion at this point in time. So I'm just going to invite all of our speakers back up to sit at the front here, basically. We'll organise ourselves a little bit. So please bear with us while we do that.